Now see, we have different kind of substances. We have conductors, we have semiconductors, we have insulators. So here I am just going to classify into two categories first, then I will explain you the third one also. So if we talk of any substance or any device or any material, that whether it can conduct electricity or not, it is divided into two categories, conductors and insulators. Conductors are one which can actually allow current to pass through it, The reason being is that why they allow current to pass through it, because they have free mobile electrons. That means electrons which are free to move. So any material which have free mobile electrons are good conductor of electricity. And talking of insulators, insulators are those which do not allow current or electricity to pass. The reason being is they have no free electrons, no free mobile electrons. They don't have free mobile electrons. So here we have certain examples for that. So conductors are silver, copper, aluminium, lead, tap water. See, tap water is a conductor, but when you talk of distilled water is a pure form of water, that is poor conductor. Distilled water is not at all good conductor, it is poor conductor. Likewise, tap water is a good conductor. Gold, brass, tin, human body, iron, steel. So anything which possess ions, or you can say anything which which have free mobile electrons, they are good conductor of electricity. Insulators which do not have free mobile electrons, they are plastic, glass, cotton, wood, silk, rubber, leather, nylon. These all are insulators, they don't conduct electricity. There is another third category, that is semiconductor. It is not included in your syllabus, but I told you when I was discussing the solar cell at that time also. Semiconductors are those which allow moderate amount of current to pass through it. Means they allow a smaller amount of current to pass through it. That means they are not fully insulator and they are not fully conductor, they are intermediate of them. They allow current to pass through less than conductor but more than insulator. So we say that they allow moderate amount of current to pass through them. Example is germanium, silicon, they are all semiconductors and they are used in making solar cells. We discussed there also. So any substance which possess free mobile electron is a conductor, and any substance which do not have that free mobile electron, that is called as insulator. Now suppose if I give you a certain substance and I ask you to prove that whether it conduct electricity or not, then how can you show it? So before we discuss about that how can we prove that it is a conductor or an insulator, so we have to take up another topic, that is the circuit. What is an electric circuit? Electric circuit is a closed path in which the current flows. It is actually a closed path. So and whenever we are drawing a circuit, we need to draw a symbols for the things used in it. So we are just going to discuss means the symbols for the things. See, if you need to denote bulb, you will be denoting like this. I think you got it, like this, this and this. Right, and when the bulb is glowing, just put small lines here, it proves that the bulb is glowing. Second is the key. Key is the switch actually, you can also call it as switch. This is a closed switch, this is a closed switch. See, whenever the key or the switch will be closed, that means the circuit is complete and the current will flow. I will write here, closed, when it is closed, that means circuit is complete, and that means current flows. And this closed key is also denoted like this also, a big line with two dots. That also means the closed key. Open key is like this, you can see that it is not being joined here. So that means it is open key. Open key means open circuit. Open circuit means circuit incomplete, it is broken at certain place and no current will flow through it. Third is the wire. We know that we need a wire to connect devices. So wire should be made up of conductor, and we have already discussed about conductors. So this is how you will be showing the wire, that is the straight line. Ammeter. Ammeter is shown by this way. An ammeter is a device which is used to measure current in a circuit. It is used to measure current in a circuit. Next we have voltmeter. It is noted like this, and it is used to measure potential difference in a circuit. See, potential difference is just a measure of charge, and if there won't be a potential difference, then the electric current won't flow. Suppose you are introducing a battery or a cell into a circuit only for this reason, because it has two poles, positive and negative, and two poles are never going to have same potential difference. There will be always difference in charges between them, and this will just make possible for the movement, the movement of the electrons from one place to the another, right? So that means there should exist a potential difference if we need to have a current in anything, in a circuit. Galvanometer is again an instrument used to measure current. Now you must be thinking that ammeter is also used to measure current and galvanometer is also used to measure current. Then what is the difference here? See, galvanometer is used, can even measure a very small amount of current. It can measure a very small amount of current also. And cell is denoted by this one big line and small line. As I told you, big one is positive terminal and other one is the negative. When you connect more than two cells together, it becomes a battery like this. Like this. This is resistance. You denote the resistance by this. See, every appellants has certain resistance. Every appellants has certain resistance. What is resistance? It is the obstruction to the flow of charge. Resistance is the obstruction to the flow of charge. It is just similar to that. Suppose we are moving if we are driving a car on a busy road, so what happened? You cannot drive smoothly. There will be a chance of collision between different cars. So that is the reason we say that is actually a cause of obstruction, and that obstruction is called as resistance. And every appellants, every conductor or every appellants, they have resistance high to low, ranging from high to low. Rheostat is that which has variable resistance. That means whose resistance in our hand, we can change its resistance. We can change the obstruction in order to, in accordance to the current. If we need more current, we can make the resistance lower of the rheostat, and if we need large amount of current, we can just increase the resistance. So these are the symbols which we will be using in order to make a circuit. Now, suppose I ask you, I give you a tap water, say, or if I give you a distilled water and I ask you that just prove me that which is a conductor and which is an insulator, how you are going to show it? See, suppose you first we will be introducing a cell or a battery. See, this is my cell, then I have an ammeter. Suppose here you say that we take wire, this is my wire, and here is my bulb. What I do is, I have a beaker here which is filled with, let's say, distilled water. Both the wires ends are just cut and dipped here. Right. Now, we know that if the circuit, we will just introduce a key also. Let us introduce a key also. Here my key is open. Now I just switch on the key. See, it is open like this. I draw like this. This is open, and when it is closed, I just put this line. So let's say that this is a closed key now. Now the current is flowing, right? So if it allows the current to flow, then only the bulb will glow. Otherwise, the bulb won't glow. So, and secondly, we need to focus that the circuit must be completed. There should not be any disconnection between the wire. So we see that if it is a good conductor, then only the bulb will glow. But if we arrange the apparatus like this, we see that bulb does not glow, indicating that this is a poor conductor of electricity. But if you replace it with tap water, now let's take that this is tap water, we see that when we arrange the circuit like this, the bulb starts glowing. So this proves that it is a good conductor of electricity. So this is how you are going to prove it, that whether the substance is a good conductor or whether a substance is a poor conductor of electricity. So this is what is the circuit. Suppose now a rough circuit I am just drawing, like if somebody asks you to draw a circuit, see, draw like this, introduce a battery. Let's say this is a battery, a key, a ammeter, wire, and let's say a bulb, like this. So this is a circuit, and this is positive terminal and negative terminal, ammeter for measuring current, key or a switch in order to on or off, and that is the bulb. This is how you are going to draw a circuit. And moreover, if you need to add voltmeter, galvanometer, then you can do it accordingly as per the need. Like if it is there in the question that include these things, then you need to include these things. So this is the basic structure which we have discussed. Now if we talk of the direction of current, so in external circuit, current flows from positive terminal to negative terminal. In external circuit, the current actually flows from a positive terminal to a negative terminal, and in internal circuit it moves from negative to the positive. So this is how you are going to draw the circuit. I think you got it. Now let us discuss about the household circuit, that how we are getting electricity at homes, or what is the you can say reading of the meter means, and how we connect the wires at home. So just look at the board.